Second quadratic surface, I am going to discuss the hyperboloid of one sheet. I just see we're having here plus sign, we make it minus sign. So we have x square upon a square plus y square upon b square minus z square upon c square. Why we say is hyperboloid? When take x equal to 0, yz plane is y square upon b square minus z square upon c equal to 1. No, due to minus, we say this is a hyperbola. Then we take y equal to 0, I get here x square upon a square minus z square upon c square equal to 1. It's again hyperbola. When we take z equal to 0, we get here x square upon a square plus y square upon b square equal to 1. This is an ellipse. So we are having 2 times hyperbola. So I call it as hyperboloid. Because I will discuss you, because we are having 2 hyperboloids, 1 sheet and 2 sheet. We may make the difference between them, why we say it 1 sheet. So then we can see, we can write this x z square upon c because on the other side, we get x upon a square plus y square upon b square is equal to 1 plus z square upon c square. For each value of z, plus or minus, we get here the ellipses and only the value of a and b will be increasing. Now if I look on the sketch of this one, when we take yz plane, this is my z-axis, y-axis, this is equal to minus b plus b and then c. We're having this as our sketch for the z-axis, yz plane is a hyperbola. In xz plane, this is my xz plane, this is my z-axis, and this is my x-axis, my origin. And I can show you my asymptotes as I told you, and then I can sketch it, and this is also my hyperbola because we have minus sign. Now then we have here plus sign, this is my ellipse. So as I said, when z is bigger than 0, absolute value of z, it can be minus, it can be plus, we get expanding way of our hyperbola. So now we can, I see you in 3 dimensions, this is my z-axis, and this is my y-axis, and this is my x-axis. Now as I told you, we're having in an xy plane, I take a yz plane is my y-axis, and this is my z-axis. I say this is my hyperbola, this is coming like this is my hyperbola, going like that one, this is my hyperbola. Now I have my xy plane, in xy plane I have the ellipse. So this is my a, minus a, my a, and this is my b and minus b. So when I take my ellipses, then my ellipses are like this one. This here is my base curve, and I have here the ellipse. Now this is my 0. Now when I increasing my value of z, then these are increased. This is my ellipse are having the value of a and b, the major axis and minor axis are increasing. Also here the major axis and minor axis are increasing. So this is here parallel to y-axis. Also this is parallel to y-axis, and I can extend this one also. Now when I take here xz plane, then xz plane we are having here, this is my parallel to z-axis, is parallel to z-axis. I have this hyperbola. This is my hyperbola in xz plane. This is my hyperbola in xz plane. So this is the idea that we are having here, the hyperbola. I just remove this one because I don't have space here. So this is my hyperboloid of one sheet. I can increase it if we can take it more accurately. I can just see that I remove this part of my equation. That's my ellipse, and my z is increasing. I can have here the value of z, and with the value of y and increasing z, value of a and z are increasing. Here it's my, and then I am going to get here these are my hyperbola, and this is my hyperbola. This is my hyperbola, and then I am having here the ellipse in this case in yz plane. This is my ellipse in yz plane. So that's the idea I am having here for the hyperboloid. So this is my hyperboloid. This is my z-axis. This is my here z-axis, and this is my y-axis, and here is my x-axis, and this we say the hyperboloid. This is like a chimney. If you see in the work of the nuclear power plant, we are having the chimney like this one for the exhaust. This is like the chimney, and we call this one a hyperboloid of one sheet. Again repeating, we are having here the paraboloid plus sign, and the hyperboloid we get here minus sign, and when we take x equal to 0, this hyperbola. We take y equal to 0, this is removed and it's hyperbola. When we take z equal to 0, we get an ellipse. Then we are having here the graph of this one. We are having this hyperbola in yz plane, hyperbola in xz plane, and then we have ellipse in our xy plane. This is my here y-axis, is my y-axis, and this is my x-axis. So I combine all the three, all of my 3 sketchings of the conic section, the hyperbola and parabola, and get here a picture like this. and this picture is known as hyperboloid of one sheet, because we can make it. You can see if I take the sheet and we can just make it like this one. I can make from one sheet, this is hyperboloid. So if, for example, this is fixed, the value of this one is not depending upon z, and the value of z is some fixed value, so this will be the circle, and it will become a cylinder like this one. We say here, when we have the value of a, b, c are equal, then we are having cylinder. So we are having the picture like this for the hyperboloid of one sheet. Now, it's very interesting, if we take here not one negative sign, we take here two negative signs. We get here one more negative sign, that's here minus. So this is my number 3 was number 2, number 3, and because of 2 minus sign, this become here hyperboloid of 2 sheet. Now you can see we can just take it, when take x equal to 0, I'll get here minus y square upon b square minus z upon c square equal to 0. When I take y equal to 0, I have the same equation, and when I take here the value of z equal to 0, then I get here minus sign. So here this change. Now this is hyperbola. Now here this is not hyperbola. It's not hyperbola. It's no shape. It's nothing, because we will get here, this is x square upon a square plus y square upon b square is equal to minus 1. This is not real. So we don't have any graph at the point when take x equal to 0. Now what happened? When I take this one, z square upon say square other side, I'll get here minus sign, and I get here, and I'll get there the plus sign. Now I take here, instead of this one, I take this equation, and I can write here, I take the value of x square upon a square to the other side. I'll get here the equation like this one, that is here I'm getting x square minus y square upon b square minus z square upon c square is equal to 1 minus x square upon a square. Multiply minus, we get here y square upon b square plus z square upon c square is equal to x square upon a square minus 1. Now if this value of x square minus a square minus 1 is bigger than 0, then you can see we'll have the graph. And when this is less than 0, we don't have the graph. When this value x square upon a square minus 1 is bigger than 0, then we'll get the graph. So we take here this x square over a square minus 1 is bigger than 0. Bigger than 0 or less than 0 is not equal to 0. I just want to say is bigger than 0. So I get here x square upon a square is bigger than 1, or x square is bigger than a square. I take the root of both sides, absolute value of x is bigger than a. That means x is bigger than a, or we say x is less than minus a. If x is bigger than a, x is less than minus a, then we have the graph. But when we are having x equal to a, this becomes 0, there is no graph. X equal to a, when we hear x equal to a, then the other values will be y equal to 0 and z equal to 0 for value of x equal to plus minus a. With plus a or minus a, we'll get here the values. This point will be plus a 0 0 and minus a 0 0. Now the situation is like this one. We are having here, this is my x-axis, for example, and this is my 0, and this here is minus a, and this is my a. So this is telling us that we having here, we have the graph here in between a and minus a, between here x bigger than a, we have the graph. We have x less than minus a, we have the graph, and there is a graph in this area, there is a graph in this area, and there is no graph here in this area. That's why we can't make it by one sheet. I say this is hyperboloid of two sheet. I just make a quick sketch for this one, and to give you the idea. We're having here z-axis. This is my y-axis. This is my z-axis, and here is my x-axis. This is my x-axis. This is my a, and it's my minus a. There is no graph in between, and there is a graph other than that. So when we are having here the values of x equal to a, then this is a point. This is a point. And we take yz plane. Yz plane is our hyperbola. This is our hyperbola. Also, this is our hyperbola in yz plane. Also in our xz plane, this is a hyperbola. And then in xy and in yz plane, we are having here the values in yz plane when this is an ellipse. So we get here the ellipses for each value. We get here ellipse, and we get here ellipse. We get here ellipse, and here also we get the ellipse. We get here ellipse. We get here ellipse. For each value of z bigger than c, we get the ellipse. So these are the ellipse we are getting, and we are having here the hyperbola in yz plane, and this my 0. In xz plane also is the hyperbola. You can see it here, it's being hidden like that because we will take here the x-axis. We're having x-axis, and we take z-axis, and we get the graph like this one in yz plane. In xz plane, we have the graph like this one. So this is how we can find this, because we can't make it from one sheet. So we say we need to use 2 different sheets for this one. That's why we call it as hyperboloid of 2 sheet. Again, a quick revision for this one. We're having the paraboloid, this was plus, this was plus. Then we're having the hyperboloid 1 sheet, one of value is minus, this was plus. Hyperboloid 2 sheet where both are minus. Any 2 values can be minus. Here I just taking y and z as minus. So when x equal to 0, we get minus y square upon b square minus z square upon square equal to 1. And then there is, because we multiply minus, we get x square upon a square plus y square upon minus 1. There is no graph. So when we take y equal to 0, we are having the hyperbola. When we take z equal to 0, we have the hyperbola. And then what we do, that there is no graph, then we solve this one. We take this value to the other side, multiply with minus, we get y square upon b square plus z square upon c square is equal to x square upon a square minus 1. If this is bigger than 0, our graph will be ellipse. If it is bigger than 0, we have the ellipse. So when it is bigger than 0, we solve this one. We are having this x square upon a square minus 1 bigger than 0. Absolute value of x is bigger than a, then x is bigger than a, or x is less than minus a. So this is our graph. Here we have the graph, ellipse. We have the ellipse here. We have the graph as ellipse here. And also we have the graph as ellipse here for different values. And then what about the point when x equal to a? When I put here x equal to a, then we are having the values y square upon b square plus z square equal to 0. And y square upon b square takes z square and c square, this become imaginary. This only graph when z equal to 0. When z is equal to 0, then y equal to 0. So get the point plus a 0 0 and minus a 0 0. So this is a point here, and this point is here. And then we are having the graph as the ellipses, and graph as the hyperbolas in yz plane and in xz plane. So inshallah we'll continue with more problems and more idea next time. Again, I am having my notes in the description, the references given in PDF file. You can take from here. We have discussed 3 of the cones. This is paraboloid, the hyperboloid of 1 sheet, and hyperboloid of 2 sheet. We'll discuss next time cone and paraboloid, and then hyperbolic paraboloid and elliptic paraboloid.